Okay, so when it's hello everyone. Okay, I think okay. Thank you very much. Welcome to my presentation. My name is Bartłomiej Rutkowski. On daily basis, I work for TrueFi, but other than that, I'm as well a contributor to a few open source projects, of which one is Waffle, smart contract testing library. And today, I'd like to tell you a little bit about this. So, starting with some general ideas, we all know that testing is a key to the smart contract security. Obviously, we have formal verification, we have auditing, we have manual tests and just like checking everything works, but these only can be additions, and these can only ensure you that everything is fine, but this is not something that you can work with on daily basis. You need to have a suite of automated tests that are gonna ensure you that everything that you write, everything that you code is working on the spot. It's not like you can create the whole smart contract system and then like check if it works at the end. You need to be sure of each line all the time. And in order to have that, you need to switch to the next slide. No, not this time. Middle button. You can help me. Whoa, nice. So, in order to have that, you need to have a swift and lightweight library, and that's of vital importance. Why? Because if you want to write these tests all the time on daily basis, then it needs to be easy to do so. It cannot be cumbersome, it cannot be inconvenient, it cannot be hard to set up. You just need to do it with a smile on your face, you need to do it with pleasure. So whenever there is a Solidity line of code, then there needs to be a test for that. And if you're not doing this, then there is a room for improvement. Ideally, the slides would be changing on the button click. The middle one, you say. Okay, no worries. So ideally, this framework would allow you to work in a test-driven development system, which probably some of you know. This is this idea that you write the test before even coding the logic. So you basically write the test that expresses a claim about the logic that you would like to see. Though the logic is just not there, you see first the failing test, and then you write the Solidity code or like the actual code to fulfill that logic. So, as we know, the, let's say, core assumptions or the key needs that we have around the testing frameworks, I think we can outline two main ideas of how to test Solidity smart contracts, or generally like smart contracts, with sort of like native frameworks, so the ones written in Solidity, like, for example, Foundry, or the ones written in JavaScript or TypeScript. So I'm not going to focus on the Solidity ones. They are brilliant, though I still think that TypeScript and JavaScript testing frameworks have some very strong advantages and are still worth considering. So just to point them out, for me, they're like far easier to use and far easier to work with on daily basis. They're far more flexible because it's super easy to code, to create that framework and to add any feature that one would need in the future. And they are sort of DApp native. And what I mean by that is that the way you test the smart contracts is sort of the same thing how users then use these smart contracts. So it's not only like making some internal assumptions about the state of the smart contract under some certain conditions, but this is actually deploying smart contracts and actually interacting with them with a JavaScript code, so the things that would happen then with, like, for example, DApp. So the DApp interacts with smart contracts, performs the transactions, checks the state, and this is exactly what happens in the TypeScript or JavaScript testing suites. So now to walk you through the possibilities of the Waffle library to see how you can achieve these goals and how sort of the tools that Waffle provides help do all that I talked about. So first, the setup. Setup needs to be super, super simple. And that's I would say the whole setup. So you create a network provider, so the object that allow you to interact with the virtual JSON RPC, and you create wallets, and that's it. No further work required. Then you just need to deploy the smart contract, also super easy. You have deploy contract function out of the box with Waffle. You just pass the wallet that's gonna be a deployer. You pass the product of the compilation of Solidity and arguments to the constructor, and that's it. So if you have the setup and the deployment, which took in total like, I don't know, less than 10 lines, then you can start testing. And here, this is also pretty easy and very verbal. So you can read the line and know exactly what the line is testing. You literally expect token balance of the wallet address to equal some number, which not only allows you to test the code very easily, but also creates sort of a written documentation of the code already. So you can make these basic assertions of any type. You can create, you can call, you can create or perform any read call to the smart contract and then assert the value in any way. And what's important, it doesn't necessarily need to be equality. Obviously, it can be, we can expect the number to be larger than or smaller than, but also we can expect it to be within range or close to some value, which sounds tricky because we don't want, in theory, in Solidity, something to be close to something. We want exactly the value that we expect. Though, in some cases, if you create your smart contract system based on time, not the block numbers, you might, for example, expect that you are not sure what the time will exactly be at the time of execution because the timestamp is not like super predictable. Then you can use the close to, dangerous tool, but it is there for you, and if you feel that it might be useful, then just go for it. And a very cool feature which also addresses sort of the DApp nativity, if I can say so, of the Waffle framework, which is testing the events. So the events are not that essential for smart contracts themselves, many would say, because they do not modify the state. They probably won't allow to steal any funds. This is not a thing that is essential to the smart contract itself, but it is still very important for the whole system that is using these smart contracts. So for example, a DApp. DApps or some backend workers or some other tools that interact with smart contracts very often utilize events to sort of source the data about the transactions, about the user activity, so on and so forth. And here you can test that very easily. You can just expect the, and here actually I would point out to the first argument of the emit matcher. You point to the exact contract that should emit the particular event. So we can, for example, perform like a transaction that like token transfer, but then at the same time you can expect some completely different contract to emit some particular event with some particular arguments, which can be quite powerful. And these matchers obviously can be chained, so you can expect many contracts to emit many different events in one transaction if this is something that you want to have. And the next thing is testing external calls. So we do not only allow you to assert the state or check the events, but also you can check whether some certain transaction was performed within the whole call stack of the transaction. So here it's like a very simple example because you like explicitly call balance of and then you expect the balance of to be called, which is quite obvious, but it applies to internal transactions only. So you can check whether your contract was, for example, correctly executing external calls and whether it's correctly integrated with external systems. And of course, you can like pass arguments to that, so it's not only checking whether the call was performed, but as well if it was performed with correct arguments. And the reverts, because obviously not every transaction needs to be successful. Actually, probably most of the transactions should not be successful, and we always have a long set of requirements and restrictions around many smart contract interactions. So we obviously provide you with the ability to test whether the contract reverts properly. And it's not only about the reverting the smart contract generally, but you can also provide the exact message that you expect the contract to fail with, so you know that the reason that you are testing is actually the thing that you expected it to fail, that the reason is correct. You can use regular expression for that, so you have like slightly more flexibility around that, and you can just be sure that you cover all of the cases. And this is a new feature because recently there are custom errors added to Solidity, so you can also test sort of the custom part of the error, whether the error was or the revert was emitted with correct arguments. And probably last one of these like matcher type of things, which is like a little bit of like syntactic sugar, because we also want to make common tests as easy as possible. So of course we will not encode each thing as a matcher, but for example the thing that is very often checked and is like a very popular test case is whether token balance or ether balance changes after a particular transactions. So you get that out of the box as well. You can test it for a one address or for multiple addresses, and obviously token transfer is super simple example, but you can have like a vault.deposit, whatever, and then check whether the balances of the LP tokens changed or whatever else. So quite powerful. And looking into some more advanced features rather than just like simple assertions. First would be mock contracts, which are super helpful if you're writing, if you are somewhere in the middle between unit tests and integration tests, because with unit tests, obviously, you want to test like the internal state changes. With integration tests, you probably want to set up the whole thing. You want to set up your system alongside with other DeFi protocols and check out whether the interactions are correct. So for that, you would need to fork the whole network, which you can do with Waffle as well, or use the testnet. But sometimes you just want to be sure that your smart contracts react correctly to what other smart contracts do. And you can do that by deploying a mock contract. That would be just sort of a puppet that then you can control and program its methods. So the mock contract on a particular method will have a particular endpoint, a particular function, and will just return the desired value, or will revert on in the desired situation. So here you can see like the whole example. So for example, you can create a mock contract and then just perform more complicated checks that depend on external smart contracts. So here, obviously, very easy situation, but you can, for example, create a mock for a compound pool, for Uniswap pair, for whatever else, and then just very easily check whether your smart contracts are gonna be behaving correctly under different conditions. And moving forward, fixtures, because this is also a very important one, because I started with the comparison, or like I set up this comparison between the Solidity tests and the TypeScript tests. Okay. I'm very close. Between the Solidity tests and TypeScript tests, so the TypeScript and JavaScript are usually not that performant. So fixtures allow you to sort of pack some setup for the tests, then perform a snapshot of the whole blockchain, and just load the whole snapshot when the test starts. So you do not need to redeploy the whole thing or rerun or clean the whole state whenever you want a new test. You just sort of like return to the state from a particular block, and that's it. And last final thought is that obviously these features are very cool, but a lot of people, for example, use Hardhat or other frameworks and just want their setup. Maybe some of this like is interesting, but still, they want to have their environment as they have it. So good news, because Waffle can be used as a plugin for Hardhat. So most of these features that I described here can be just used with other frameworks without additional effort. Summarizing, I will not because I'm out of time, but you already heard everything. So thank you very much for your time. Thank you very much for attending. If you have any questions, just shoot.
Is it working? Yeah, unfortunately, we have not really a lot of time. But yeah, I guess you can ask at any time just after.
Cool. So thank you very much.
Yes, sorry for the time.